Good morning, good afternoon. I think the stream is live. Please let me know if you can hear me by chatting in the comments. Um, Today, we're going to look at trigonometric identities. Um, Hoping you can hear me. I'm not sure what you can see just yet. Just chat in the comments if you can say if you're here. This is great. Today, I wanted to talk about trigonometric identities. And I didn't want to startle or scare you, but I just wanted to display all of the trigonometric identities that we've got this year. If you are watching, can you just comment in the chat so I can see that this is working? Thank you. So this year we've got a whole range of trigonometric identities, and I just wanted to quickly outline. Oh, hello, Joshua. Quickly outline what they are. So first off, we have the trigonometric ratios. So we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But now, this year we've got a few more. And so I've just listed them over here. We've got cosec, which is the reciprocal of sine. We have sec, which is the reciprocal of cosine. We have cot, which is the reciprocal of tangent. And since tangent is sine over cosine, the reciprocal of tan is cot, which is cosine over sine. Now, oh, fantastic. There's a few of you watching. This is outstanding. So let's hope more people come along soon. All right, so those are the main identities. I'm just going to ask you to just quickly have a look at the screen. I'm just going to close a curtain, and then I'll be right back. Sorry about that. I just had light blaring into my eyes. So, these are the three new trig functions that we have. And then we've learnt the Pythagorean identities. These ones here. So these ones here, the Pythagorean identities are really important. They come from knowing Pythagoras. Based on how Pythagoras' formula of a squared plus b squared equals c squared. If you take a right triangle with the hypotenuse of 1, you can come up with these three identities. And I think they become the most ubiquitous trigonometric identities that we have at level 3. Okay. Now, after those three identities come the compound angle identities down here. Compound angle identities are really useful for looking at when you have shifts of phase or shifts in trigonometric expressions and how you can re-express them in other ways. Typically, you'll see things like sine of x plus pi. How else can you write that? Or one of my favorites, sine of plus pi on 2. What does that shift to? And so you will see some really cool, interesting things that happen. And we'll look at these in a little bit. I'd also like for you this time, whilst you're listening, as identities require lots of proofs, if there are any particular questions on identities that you have, I want you to write them in the comments in the chat now, so that when I read them, I'll be able to respond to them and we'll be able to do some identity questions. This one's going to be a little less formal than yesterday. So those are the kinds of things compound angle identities are used for. So if you have a page number, just go like page something, this question, and I will look at it during this live chat. Okay, compound angles are done. Now, the next set of angles that come quite naturally after compound angles are the double angle identities. The double angle identities come from the fact that if A and B are the same thing in the compound angles, then you have kind of special cases of the compound angle identities, and they become the double angle identities. You can sort of see that because if A and B are the same, then this is sine A cosine B, and this is sine A cosine B. And so it's 2 sine A cosine A. That's why it is a double angle identity. The tan one looks a little scary, but it's familiar because it's the same over here. Cosine is the only one that looks a bit scary. The reason being, it's got a sine squared and a cosine squared. And the moment you get a sine squared or a cosine squared, you can once again use our Pythagorean identity to ask another way of writing it. And that's why it's really, really important that we recognize the Pythagorean identities as really, really useful identities for us. Okay, so these are the identities. And given that you'll be given a formula sheet, it's not like you need to memorize them, but you kind of need to see that these will become very useful to us. Now, if not the most practical identities, the most usable identities we will find are the products to sums, or this should say products to sums. I'm going to see if I can change that. So that's the products to sums identity. So that's the products to sums, and these are the sums to products identities. These identities are substitution identities, I like to call. These identities are useful when you've got something that looks like a product, so something times something, and you want to change it to something plus something, because pluses are really nice to deal with in some situations. Or the backwards version, when you've got a plus and you want to go to a times. These are the same things, but I've used C and D from your formula sheet just to show that there's a slight difference in how you go about it, but you can pretty much use these quite interchangeably. So those are the identities I feel are very, very useful, very common. However, because identities are conversations about things that you can arrive at from different trig expressions, you will find that identities, there's plenty of them. As you go through your maths, you'll find more and more identities. Other people will find an identity and start using it a lot more. And they'll go, this is my new identity. And so you'll see the word identity being used to describe more than just what you see on the page right here. So I don't see anyone in the chat having suggested any questions that they want to look at, which is kind of disappointing, but I've got some that I've prepared and I would like to look at. So I'd like to start off by looking at a few identities near the Pythagorean identities, because they are kind of the ones that you see very, very often. They're the ones that often people use more often than everything else, and so yeah, let's give them a go. So okay, hi Jason4. You haven't told me what questions you want to do, Jason4. Tell me what questions you want to do, Jason4. So one of my favorite Pythagorean identities, and if you have your workbook, this is from page 55 in your workbook. This is a question that I really often like because I think unpacks a lot of the Pythagorean identities that you need. So the question is, prove that tan of x plus the cotangent of x is equal to the sec of x times the cosec of x. I'm going to leave this up. I'm going to get you guys to give it a go. So this is question 1E. Okay, I'm going to leave this up. If you have a pen and paper handy, give this a go, and I'll try to answer it using these identities in about a minute. Okay, so I don't know if you guys are working, so just say we're working if you are. But I'm going to start. I'm going to show you how I think about doing this. Whenever I look at an identity, I always pick one side to start with, typically the left-hand side, and I try to reach the right-hand side. So I'll say the left-hand side is equal to tan x plus cotangent x. Okay, and then I'm going to try and do something. I know that tan is sine over cosine, and I know that cot is cosine over sine, and that's from the identities above. Perfect. Lucy, you can see the identities. That's good. But can you see what I'm working on? So I'm going to plug these in. Sine x over cosine x plus cosine x over sine x. Now, what I might want to do is, given that they're two fractions, I might add them together. And the way I do that is by multiplying these two together, then multiplying that by that, and that by that. And let's see what happens. Sine times sine is sine squared. Okay, and the denominator is sine x times cosine x. Over here, cosine times cosine is cosine squared. Over sine x cosine x. Now, given that the denominators are the same, I can add the numerators. And so sine squared plus cosine squared is equal to, well, think about it. Sine squared plus cosine squared is equal to 1. And so I'll make that substitution, and I have 1 over sine x cosine x. And if I split this back up, I get 1 over sine x times 1 over cosine x. And with our other two identities, we know that 1 over sine is cosec, and we know that 1 over cosine is sec. And so we have the right-hand side, and there ends our proof. Okay. Does that make sense to you all? Now, the thing is, in these questions, the hardest part of the proof is knowing what substitution or what manipulation you need to do. Often it's knowing when to use a Pythagorean identity or when to use another identity, but it might be the case that some of them are really easy and some of them are not so easy. So I'm going to move on to doing another type of identity. So we've done Pythagorean identity. I'm going to use a different type of identity. Let's see if you can figure out what kind of identity I'm going to need in this question here. All right. Okay, so this question here, if you want to follow along in your book, I'm going to do from page 59, question 2e. Okay. This question is really looking at how you unpack an identity. There's actually a couple of ways to do this question, and I'm gonna start by suggesting that you should probably always, when you're doing identities, manipulate the quote-unquote ugliest looking part. Right? What side looks worse? I'm going to leave this up. What side looks worse is a really subjective question. We could say that because the right-hand side looks so messy because it's got lots of terms, we could probably start with the right-hand side. Or you could be a person who says, no, in fact, this 4 is probably the most awkward part in this identity. And so I'm going to actually work and try to figure out how to deal with this 4. Either which way, you're fair game to start either way. So for today, I'm going to start this identity by looking at the left-hand side. Cosine 4x. Okay. Try to do this independently, and if you need help, follow along with what I'm doing. Remember, I don't want to make up a new identity. I don't want to use anything too weird. And the number 2 is really useful to me. So in fact, I'm going to just write this as 2 lots of 2x. That's correct, right? Because I know that I have this kind of identity. Cosine of 2a can be written in many, many ways. I'm going to write it as this identity, 1 minus 2 sine squared a. That's a really useful identity. There's a couple more that I could use, but I'm going to use the one with sines because I notice in this question that there are lots of sines. There's a sine here and a sine here, and this is sine to the power of 4, and this is sine to the power of 3, and to the power of 2 rather, and that indicates to me that maybe I want something that has sines in it. So that's the one I'm going to use. Okay. How am I going to use it? Well, my a is 2x. And so here, I'm going to write this, but I'm going to replace this with 2x. So here goes. 1 minus 2 sine squared 2x. Now, you're like, that looks pretty scary. Yes, it does, but this is a stepping stone. This is somewhere we can start. What do we need to do now? Well, you might notice that another way to write this is sine of 2x all squared. That's cool. What's another way of thinking about it? Well, sine squared has some identities that it can go to. Does this seem like a good plan? It might not be the best plan, because what happens when you have a sine double angle identity? Well, a sine double angle identity will give us 2 sine A cosine A. And now we've got cosines again. So maybe this wasn't the smartest identity to use. Does anyone have another suggestion as to what could be used? Oh well, I am going to use it, see what happens. It can't possibly be terrible. And the reason I'm doing this the way I am is because I think it's really important to realize that you're not going to always get your identities right the first time around. And you might have to do something that is a little out of left field. Yeah, Yuan Chen? Yep, that seems like a reasonable thing to do. 2x into another. Well, no, if it was a cosine, Lucy, then I would be able to. But I don't have a cosine, so I have to do this, what Yuan Chen said. Okay, now what I'm going to do is I'm going to actually expand and see what happens. I have minus 2. I'm squaring every term in here. So I have 4 sine squared cosine squared. And then I'm going to just scroll down a little bit, and I'm going to multiply. 2 times 4 is 8. Now, this kind of looks really far from this, but actually, there's an identity that's really useful to me. And it's one of my favorite. We have the sine squared plus cosine squared is equal to 1. And so, since there's no cosine squareds in the original, I know that I can rearrange this and get cosine squared is equal to 1 minus sine squared. And that is the Pythagorean identity. And look what happens when I substitute this. 1 minus 8 sine squared, and cosine squared is 1 minus sine squared. And let's expand. 1 minus 8. 8 sine squared times 1 is just 8 sine squared. And maybe I'll just put the bracket here. I'll just times the sine squared in. And sine squared times negative sine squared is negative sine to the power of 4. Boom. And that is equal to the right-hand side. And we are done. I'm going to leave this here for you to process, think about, and ask questions if you want to. It's a very interesting way of going about it. But the scary part is coming down to this part here and deciding what to do. Because you can't guarantee that this is going to lead you to a nice place. And this is the thing with trigonometric identities. You've got to try. Sometimes you make a mistake. Other times you get the right place. But you've got to take a leap. You've got to trust that what you're doing might be correct. And hope that it will continue. Okay? Now, does anyone have any other question they want me to look at? Cool. I'm going to skip these ones, and I'm going to do an identity for us that involves some slightly harder ones. But I've been live for 24 minutes, so I'm going to do an identity that involves sums to products and products to sums. This one's not as nice, but don't be too disheartened. Let's give it a go. Okay. And this identity is from page 62. And it's question F. Question 2F, that is. Okay, if you're following along in your book, let's give this one a go. Prove 1 plus cos 4x minus 2 sine squared 2x. I'm going to just put the 2x in brackets. Is equal to 2 cos 4x. I want you to think about this one. I'm going to leave this here for at least a minute, because maybe you could use some really cool insight to help you out. Are you going to start with the left-hand side? Are you going to start with the right-hand side? Comment if you're going to start with the left or the right. So for me, I think I could start with the left or the right. GC, I like your suggestion of starting from the right. Yeah, let's start from the right. I would have started from the left, actually, but let's start from the right and see what happens. So the right-hand side is equal to 2 cos 4x. Okay. And then what I'm going to do is I'm going to do something. Oh, a lot of you are saying right. This is interesting, because if it were me, I'd probably start at the left because I see something pretty cool happening really quickly. But I'm going to break this up by doing this. I'm going to write cos 4x plus cos 4x. So in fact, now I have 2 cos 4x. Okay? Because I noticed that in my answer, I have a cos 4x, so I don't want to mess with one of them. I'll leave one of them the same, and I'll change the other one. And then, if you call back to the identity we used just above here, well, cos 4x was also in that identity. And so you should see something very similar. And I called a cos 4x, cos 2 times 2x, and then I got to this point here. So what I'm going to do is I'm going to do some cheats, and I'm going to copy that, and I'm going to try to paste that down here, see what happens. Yep, and then what I'm going to do is I'm going to just move this all over, no, stick it right, oh, hello. I'm going to zoom a little bit more. I'll move it over just a little bit. Oh my god. Why does technology not like me? Yeah. And so now what I've got is, oh, sorry guys. I've got cos 4x plus that, then cos 4x plus that, and then cos 4x plus this. Hey, no shortcutting. I think you might be a little late. Jason, I couldn't be bothered writing that, but I've done that just before, right? And in fact, this is 1 plus cos 4x minus 2 sine 2x, which is in fact the left-hand side. And I'm done. I didn't really do any new thinking. And because of my prior experience, it made life a little bit easier, you know? And I'm not saying you can use that every time, but I thought it'd be a really cool question to carry on with, given that cos 4x was something that we just experimented with. How about that? No one yet wants to give me a question to do. Come on, guys. Throw up a question that you want me to do. Oh, can you not see the left-hand side of my board? Oh, no, you can. I don't know why. It just looks funny on my screen. So I'll do one more, and then I might call it a day, unless any of you give me a question. But this one is going to be a bit hard. It's going to be the one above it, page 62, and question 2e. Page 62, question 2e. Alright, let's give that a go. GC, I don't know if it's being alpha. It was me showing that I remembered what I did on the other page quickly enough to use it. But the thing is, it shouldn't have been too much stress for me to realize that I've seen cos 4x before. Okay, prove this. Okay, I'll leave this up for a little bit. Yes, Jason, I will do that. Yeah. Page 55 2C. That's going to be next. Yep, I can do that. That's fantastic. But let's do this one first. It's a bit gnarly. It doesn't look very pretty. But I thought it'd be a really good question to start with. Should we start with the left-hand side? Shall we start with the right-hand side? Give me ideas, team. Okay, yep, I will also do page 62 to D as well. Yep, that's fine. Left-hand side or right-hand side, guys? This looks gnarly. I don't know if I want to do either. What is my plan? Okay, I want to start on the right-hand side, Jason. Why do I want to start on the right-hand side? What do you think that will give me? Okay, Yuan Chen, you'd say right-hand side where you have 2. Okay, that times 2. Okay, that seems interesting. Oh, Jackson, you say left-hand side. Why would you say left-hand side? Okay, given that right-hand side got the most suggestions, I'm going to try what Yuan Chen did. Not too sure I like it though, because this squared business is giving me a bit of unsurety. I don't know what to do with the squared situation. Yeah, okay, the right-hand side looks more confusing, sure, but the squared situation is what I'm not comfortable with. I don't know what identity I'd use on the squared. Do you? Yeah, okay. Jackson, yeah, the left-hand side is bigger, so maybe we should use the left-hand side. I mean, that's not bad advice. In fact, I'm gonna make the executive decision, and I am going to use the left-hand side, and we'll see what happens, because I think something interesting might happen. Okay, so left-hand side. This looks terrifying, by the way. What do you think I should keep on this part? What do you think is really useful and what I don't want to get rid of? This cos 3a, does it look like something that I might want to use at some point? Yeah, maybe I'll save it, or maybe I'll do something interesting with it. But what I'm going to do is I'm going to save it for a bit, and I'm going to just use the cos 5a and the cos a, and then we'll leave this bit here for now, okay? Because maybe that will be useful to us. Okay, and I'm going to use the sums to products identity. Okay, and the sums to product identity here is this one. This is the one that says cos A plus cos B equals 2 cos A plus B over 2 cos A minus B over 2. We'll see what that does. Yeah, okay, cool. Thanks, guys. So let's see what that does. So 2 cos 5a plus a over 2 cos 5a minus a over 2. And then there's still this business here, which we'll just leave. Yeah? And let's see what happens as I go through. I'll simplify cos 5a plus a is 6a, and 6a divided by 2 is 3a. Ooh, that looks really good. And then I've got 5a minus a, which is 4a, divided by 2 is 2a. And once again, a cos 2a is not a stranger in the sense of identities that we're about to have. Okay. I strongly feel that this cos 3a business and this cos 3a business is really helpful. So I'm going to just factor that out. I have 2 cos 3a. What can I factor out? Well, there's a cos 2a here and a plus 1. And I know that my question had some squareds, cos squareds. So maybe I should use the Pythagorean, the double angle identity that only gives me cos squareds. Let's see what that one is. That is cos 2a is equal to 2 cos squared a minus 1. Let's see what happens when I plug that in. Cos 3a, and then I go 2 cos squared a minus 1, and then there's plus 1 here, and then that simplifies, and I've got 3a times 2 cos squared a, and then 2 times 2 is 4. Hey, I've got the answer. And it wasn't actually too bad. Now, for those of you who start at the right-hand side, it may have been a little bit more tricky to figure out how to get from here back to a step like this. And so I would have been very curious as to how you would have worked with the right-hand side. So if you think you've got an answer with the right-hand side, can you post it as a comment to this video, or add it to the comment in your Google Classroom to this post, and we'll see if we can make it work. Cool. All right, so I've been on for 40 minutes. I'm going to do 2 more questions, I think. I'll do question 2C on page 55, and I'll do question 2D on page 62. Okay. Okay, 2C on page 55. Oh, 2C looks pretty scary. Page 55, question 2C. All right. Beatrice, is this you? No, this is Jason. Cool. 1 minus cos theta, 1 plus cos theta equals 2 cosec squared theta. Okay. Would you start with the left-hand side or the right-hand side for this question? For this kind of question, I think starting at the left-hand side where it's more complicated will be the best thing to do. So I'm going to go left-hand side is equal to 1 minus cos theta and 1 plus cos theta. And it's really important that you can see that these are actually different by a minus sign. And so when you multiply them, you still only get 2 terms. So let's try it. Let's multiply by going that times that, that times that, and then that times that, and see what happens. 1 times plus cos theta is 1 plus cos theta, and the denominator is 1 minus cos theta times 1 plus cos theta. And then this fraction is 1 minus cos theta. The denominator is 1 minus cos theta times 1 plus cos theta. Okay. Now I can add the numerators. So I have 1 plus cos theta plus 1 minus cos theta all over 1 minus cos theta, 1 plus cos theta. If you simplify the numerator, you get 1 plus 1, which is 2, and the cos. And then 1, if you expand the bottom, you get 1 minus cos squared theta. And what's another way of writing cos squared theta, or 1 minus cos squared theta? Well, if you go back to your Pythagorean identity, where you've got sine squared plus cos squared is equal to 1, you will get that sine squared is equal to 1 minus cos squared. And so I'm going to just substitute the sine squared into the bottom here. And so we get over sine squared. And if you look to your original identity, when sine's on the bottom, another way of writing it is cosec. And so you get 2 cosec squared theta, which is the right-hand side, which is exactly what you wanted. Okay, so these things here are really for us to realize that the identities that we use are familiar to us, or should be familiar to us. Okay, I think the last question, but I really want you to put in the comments whether you've been doing the work alongside and whether it's been making sense, okay? And whether you want me to continue doing these live streams or not. That'd be really useful, and I'd like as many people as possible to answer that so that I actually have some empirical data. Thank you, guys. So page 62, 2D. And this is Beatrice's question. Okay, Beatrice, this one doesn't look pretty in any way. Is that why you've asked for it? Okay, let's do it. So this is sine A plus 2b plus sine A all over cosine A plus 2b minus cosine. All right. Thank you, Emma. Okay, Josh. All good. Yeah, I'll try continue these live streams. All right. This one looks gnarly in the sense that it doesn't seem like a sensible thing to do. You don't know when to start, where to start, and I can promise you that it's probably not the friendliest question. But I'm going to suggest that you really quickly think as to whether to start on the left or the right. Okay? Comment now whether you start on the left or the right. Okay. I'm going to start with the left because it's well uglier. And it's not going to be, I'm not going to take any shortcuts, but the reason I've done is because I know that something pretty will happen. Because I see the B, and the only way I can, like, get the B by itself is to work to it. I can't miraculously just make up an A, you know? And so that's why I started with this side. Yeah, thank you. Yeah. Surely, right? Because if I don't have a letter, I just can't make it up, right? So let's try this. And what I'm going to do is I'm going to just look at the top, okay? The sine. That's sine plus sine. And remember your identity. Sine A plus sine B is 2. Who remembers the formula now? Sine A plus sine B is 2 sine A plus B cosine A minus B over 2. Okay? And then I'm going to look at the bottom, and it's got a minus in the cosine. And the minus in the cosine tells me that cosine A minus, cosine A minus cosine B, well, that gives me negative 2 sine A plus B sine A minus B. Okay, and that's going to be what I'm going to start with. There we go. Well done, team. We're all starting with the left. Those two are the identities I'm going to use. Let's see what happens when I do this. All right. I have 2 sine 2A, A plus 2B plus A is 2A plus 2B. Two A plus 2B all over 2. And then times that by cosine of A plus 2B minus A, so that's just 2B over 2. And on the denominator, it's minus 2 sine, we add them again, so it's A plus 2B plus A, so that's 2A plus 2B over 2. And then it's sine A plus 2B minus A, so that's just 2B over 2. And let's simplify these. Well, this is 2 sine A plus B cosine B over negative 2 sine A plus B over sine B. And notice I can cancel the 2 with the 2, and the sine A plus B with the sine A plus B, and I'm left with cos B over negative sine B, which is negative cos B over sine B, which is negative cot B, which is equal to the right-hand side. Well done. Okay. Now, I see there are no new questions. I'm going to leave that there. I've got about 10 minutes to start my Year 12 live stream, so I'm going to leave that there. Thank you guys for your participation. Make sure you tell your friends to go and watch these videos. Make sure that they, get engaged with this stuff, because this stuff is what's going to be really important to us later on. So hopefully you enjoyed that. We did a whole range of proofs. It's really important that you practice, practice, practice. You're not always going to get it right the first time round. Fantastic team. I'll talk to you later. Bye for now.